Our next question gives us a basis and the basis is made up of eigenvectors. Okay. So to compute I beta alpha, well, this is what I does. We have to, to compute I beta alpha, we need to know what alpha is. We're given beta, and we're given that alpha is the standard basis. So alpha equals E1, E2. Well, I1, 2 equals 1E1 plus 2E2. And I21 equals 2E1 plus 1E2, which implies that I beta alpha equals 1, 2, 2, 1. Now we want to compute I alpha beta by computing the inverse of I beta alpha. The only way that we know how to compute inverses is to set up our system and apply row operations. So we subtract to eliminate our second row, we get 1, 2, 0, minus 3, 1, 0, minus 2, 1. R2 over minus 3 replaces R2, gives 1, 2, 0, 1, 1, 0, 2 over 3, 1 over 3. And now we're going to take R1, subtract R2, subtract 2R2, replace R1. And this is going to give 1, 0, 0, 1. But then it's going to be 1 minus 2 times 2/3 or minus 4/3, giving us minus 1/3. And we're going to get minus 2/3. Minus 1/3. And now we're going to get 2/3, 2/3, minus 1/3. As A prime equals I beta alpha inverse equals minus 1/3, 2/3, 2/3, minus 1/3, which equals I alpha beta. Now it asks us to compute T alpha alpha. Now, in order to know what T alpha alpha is, we're going to use the fact that T alpha alpha equals I beta alpha T beta beta I alpha beta. So what is T beta beta? Well, T beta beta is equal to the eigenvectors, the eigenvalues for our eigenvectors. So span of 1, 2 is the first basis vector, and its eigenvalue, which we can see down here, is 2. So T beta beta is going to be 2, 0, 0. And then our next eigenvalue is minus 3. So that's going to be a minus 3. Okay. Now that we have that expression, what we can do is we can fill in our matrices. So I alpha beta, we know is 1, 2, 2, 1. T beta beta is 2, 0, 0, minus 3. And I alpha beta is minus 1/3, 2/3, 2/3, minus 1/3. And now doing our multiplication, we get 1, 2, 2, 1 multiplied by minus 2/3, 4/3 minus 2, 3. Now doing our next multiplication, we get minus 2/3 minus 4, which is minus 2/3 minus 12/3, which is minus 14/3. Then we get 4/3 plus 6, or 4/3 plus 18/3, which is 22/3. Now we get 2 times, so we get minus 4/3 minus 2, which is minus 10/3. And we get 8/3 plus 3, or 8/3 plus 3/3, which is 11/3. We have our T alpha alpha. Barring a calculation mistake, this would be T alpha alpha. And now we can use T alpha alpha to calculate what T x1 x2 is. Because it's the standard basis, T x1 x2 equals x1 T e1 plus x2 T e2, which equals x1. Now T e1 is minus 14/3 minus 10/3 plus x2, 22/3, 11/3. Because this gives us, this is T e1 written in the standard basis alpha. And this is T e2 written in the standard basis beta. So technically, I should probably have an intermediate line here where I go x1 times minus 14/3 e1 minus 10/3 e2 plus x2, 22/3 e1 plus 11/3 e2, which equals x1 minus 14/3, 0, minus 0, 10/3, or plus 10/3, plus x2, 22/3, 0, plus 0, 11/3. Expanding, we get x1 minus 14/3 minus 10/3 plus x2, 22/3, 11/3. This gives me minus 14 x1/3 minus 10 x1/3 plus 22 x2/3, 11 x2/3, which equals, after all that work, 22/3 x2 minus 14/3 x1, 11/3 x2 minus 10/3 x1. And we are finished. Now, if you jump some of these steps, you'll probably get the marks. But here you'll notice each step I did an individualized thing.